In this video, we are going to go over how to find your greatest common factor of monomials. Your directions here say find the greatest common factor. In this first example, we have two monomials. One that is 2u cubed, and the second monomial is 8u. When you are asked to find the greatest common factor, you need to break it down into its factors. The first one, the 2u cubed, our factors are 1 and 2, and then there's 3 u's. On the second one, the 8u, you have a 1 and an 8, a 2 and a 4 as your factors, and a single u. What is in common to both? There's a 2 and a single u that is in common to both. So your GCF would be 2u. Let's look at another example. Here we have the same directions. Find your greatest common factor. We have two monomials. We have a 2 and we have a 2z. What is in common to both? We shouldn't even have to list them out separately this time. The only thing in common to both is the number 2. So your greatest common factor is 2. Let's look at another example. Here, what is your greatest common factor? Well, let's split it up. We have an 8r squared, so our factors would be 1 and 8, 2 and 4, and then there's 2 r's. Our factors of the other monomial, we have 1 and 6, 2 and 3, and 2 r's. What is in common to both? A 2 and then 2 r's. So our greatest common factor would be 2r squared. Let's continue to look at some more examples. What is your greatest common factor between 3w and 3w cubed? If you list out the factors, there's 1 and 3, a single w, 1 and 3, and 3 w's. What is in common to both? A 3 and a w. So your greatest common factor would be 3w. Let's look at another example. Here we have it combined together with subtraction, but you are still trying to find the greatest common factor of both individual pieces. So if we look at that first one, the factors of 12f squared, we have 1 and 12, 2 and 6, 3 and 4, and 2 f's. My factors of the second one are 1 and 3 and a single f. What is in common to both? A 3 and 1f is in common to both. So our greatest common factor is 3f. Okay, let's move on to example number 6. We have two monomials. What is the greatest common factor? Well, if we look at this, 7 is a prime number. The only factors of 7 would be 1 and 7. 7 is not a factor of 18, so the only common factor we would have is going to be a 1. But just for sake of argument, let's list out the factors of that first one. We have 1 and 18, 2 and 9, 3 and 6, and 2 c's. What is in common to both? The only thing in common to both is that 1. So your GCF is 1. Let's take a look at example 7. The difference here is now, instead of only looking for a common factor among two monomials, we now have 3 monomials. Process doesn't change. We still are doing the exact same thing. What is the common factors to all 3? So if we look at the first one, we have 1 and 16, 2 and 8, 4 and 4, and 2 d's. That middle one, we have 1 and 12, 2 and 6, 3 and 4, and 4 d's. And that last one, we have 1 and 4, 2 and 2, and then 4 D's. What is in common? What is the largest common factor in common to all three of them? That would be a 4 and 2 D's. So our greatest common factor would be 4D squared. Let's look at one last example. Here we have two separate monomials, and we are asked to find the greatest common factor. Well, my factors of 16, I have 1 and 16, 2 and 8, 4 and 4. I have 6 n's, and I have 5 p's. Factors of my second monomial, I have 1 and 32, 2 and 16, 4 and 8. I have 7 n's, and I have 5 p's. What is in common to both? The largest number in common to both is 16. 6 n's are in common to both, and 5 p's are in common to both. So my greatest common factor would be 16 n to the 6th, p to the 5th. Hopefully this helps you figure out how to find your GCFs of monomials.